Hello everyone. Let us now look at another one divergence theorem numerical problem in cylindrical system of coordinates. So let us look at the question here. In this question, given vector D is 6 rho sine phi by 2 a rho cap plus 1.5 rho cos phi by 2 a phi cap coulomb per meter square. You are asked to evaluate both the sides of divergence theorem for the region bounded by 5 sides, which are rho equal to 2, phi 0, phi pi, z0 and z phi. So let us start solving the numerical problem. I'll write with vector D, which is 6 rho. In this case, sine 1 by 2 phi is there, which is sine of half of phi in a rho cap, and 1.5 rho cos half of phi, which is phi by 2 a phi cap coulomb per meter square. And the region is bounded by 6 sides. So rho equals to 2, phi 0, phi pi, z0, z phi. So let us write the divergence theorem equation first. You can write Gauss divergence theorem or simply divergence theorem, which is closed surface integration d dot ds equals to volume integration del dot d dv. We have already discussed this left-hand side is the flux and the right-hand side is the charge enclosed. I can write here this left-hand side is flux and this right-hand side is charge enclosed. We have to evaluate LHS separately and RHS separately. Both will become equal. And the answer you should get is 225 coulomb. This should be the answer. So let us verify that. So first start with evaluation of surface integration. So let me write the surfaces here for our convenience. Then we can write the proper integrations. So closed surface integration d dot ds. One surface is rho equals to 2 d dot ds. Another surface is phi equals to 0 d dot ds. And third surface is phi equal to pi d dot ds. Then the next surface is z equals to 0 d dot ds. Then the next surface is z equals to phi d dot ds. Let us try to understand now what is the signs for each of these sides. So I have already discussed in the numerical problem for rectangular system of coordinates or Cartesian system of coordinates. We have understood for any axis, the larger value will have the positive sign. So here rho equals to 2 will have the positive rho direction. Out of this phi 0 and phi pi, the smaller value will be the negative direction and the larger value will be the positive direction. And out of the z0 and z phi, the smaller value will be the negative z direction and the larger value will be the positive z direction. Now let us try to find dot products of d dot ds on each of the sides and try to do the integration to get this left-hand side. So let us try to evaluate the left-hand side first with the given vector d. So I will write the surfaces. First surface is rho equals to 2. For this surface, ds vector is in rho direction. We can look at the formula for cylindrical system of coordinates, the differential surface volume elements, and find the corresponding ds vectors in each of the sides. I will write directly the equation. You can refer the formula. So rho d phi dz a rho cap. Now we need to write d vector dot ds vector for this particular surface. The given d vector is 6 rho sine phi by 2 a rho cap plus 1.5 rho cos phi by 2 a phi cap. This is a rho direction. So we have to multiply the rho component and the rho component here to get d dot ds for this corresponding side, which is going to be 6 rho square. 6 rho sine phi by 2 multiplied with rho d phi dz. So it will be 6 rho square sine of phi by 2 d phi dz. And in this side, whatever is the value of rho, we should write the value of rho as 2. So we need to substitute the value of rho as 2. I will write rho should be taken as 2. By doing so, we will get d dot ds to be 6 into 4, which is 24 sine phi by 2 d phi dz. And the limits for rho, phi and z can be taken corresponding to the given volume. I'll write it over here. Rho limit is 0 to 2, phi limit is 0 to pi, and z limit is 0 to 5. So we should make sure wherever we are doing integration with respect to the corresponding variable, the lower and upper limits can be taken from the given volume specified in the question. Next surface we have to write is phi equals to 0 surface. So phi equals to 0 surface will have ds vector in negative phi direction. We can write ds vector in negative phi direction formula from cylindrical system minus d rho dz a phi cap. For this, we need to write d vector dot ds vector. We should take the component of d vector in phi direction here. So phi direction component should be multiplied with this phi direction component to get this dot product. So let us write that directly here, which is minus 1.5 rho cos pi by 2 d rho dz. And for this surface, phi should be substituted as 0. Now, when you consider here cos 0, this cos 0 will be 1. Phi should be substituted as 0. Cos 0 will be 1. And thereby, we will get the d dot ds will be minus 1.5 rho d rho dz. So this is the d dot ds vector for phi direction. And we should do similarly for the third surface. I'm using the colors interchangeably so that the next steps should look different for you. That is not a big deal. So ds vector in positive phi direction, which will be d rho dz a phi cap. Now similar d dot ds will give phi component and phi component should be multiplied. You will get plus 1.5 rho cos pi by 2 d rho dz. For this side, we should take phi value as pi. Now, when you look at here, cos of pi by 2, this is going to be 0. So, this entire d dot ds will become 0 in this case. Now, for the fourth and fifth surfaces, we should consider d dot ds. So, for the fourth surface, which is z equals to 0, which is ds in negative z direction, we should write ds vector in negative z direction, which is minus rho d rho d phi az cap. And for positive z direction, for the surface which is z equals to 5, it will be plus rho d phi az cap. But we also know our d vector does not have z component. When you look at our d vector does not have any z component. This is 0. So 0 multiplied with this z direction component and this z direction component is going to be 0. So directly I can write d vector dot ds vector for both negative z direction and for positive z direction it is 0. Now out of these 5 surface integrations, we have 2 dot products, that is d dot ds becoming non-zero and remaining 3 becoming 0. Now we have to perform integration of these 2 and add together to get the left hand side, which is the closed surface integration of d dot ds. So let us do that here. Left hand side evaluation is closed surface integration d dot ds, which gives first 2 integrations are non-zero. I will write the value directly. 24 sine phi by 2 d phi dz, where the limits for phi is 0 to pi and z limits are 0 to 5. The second integration is minus 1.5 rho d rho dz, where limits for rho is 0 to 2 and z limit is 0 to 5. The other integrations have already become 0 because the dot products have become 0. Now we can perform integration of these 2 to get the left hand side. First 24 is constant. Now integration of sine 5 by 2 is minus cos 5 by 2. And we have to consider this function to be differentiated and written in the denominator. This is the rule for integration. So cos 5 by 2, and in denominator we will get 1 by 2. The limits are 0 to pi. Then dz integration z 0 to pi. Similarly here 1.5 is constant. Integration rho d rho is rho squared by 2. Limits are 0 to 2, and dz integration z 0 to 2. Now we have to perform substitution of these to get the answers. So let me write the answer here directly. So the left hand side is going to be, this is 24 multiplied with 2 you will get, and substitution of the limits, let us do 24 multiplied with 2, and cos 5 by 2 is 0, then cos 0 is 1, so minus of minus 1 you will get. Then here for z it is going to be 5. Then 1.5 divided by 2, so I will write 1.5 divided by 2. Here it is going to be 4, and this is going to be 2. So finally, after simplification, I will get 240 here. 24 into 2 into 5. So 240 for the first term, minus I'll get 1.5 into 4, which is, sorry, I have made a mistake over here. Z limit is 0 to 5. So this should be 4 multiplied with 5. So 1.5 multiplied with 10. So it will be 15. So 240 minus 15 is going to be 225, and the unit is coulomb. Because we know the left-hand side evaluation is for total flux. So whatever we have got for the left-hand side, which is total flux leaving the closed surface, which is closed surface integration d dot ds, which was found to be 225 coulomb. Now we have to verify for the right-hand side. We are going to get the same answer. The right-hand side is volume integration, divergence of d dv. Now this is in cylindrical system. So we have to write the formula for divergence and also dv in cylindrical system. You can refer the formula and write it. So I will write directly for proceeding further. You can refer the formula. So del dot d is 1 by rho dou by dou rho of rho d rho. Then 1 by rho dou by dou phi of d phi. Then dou by dou z of dz. Then dv for cylindrical system is rho d rho d phi dz. And as we have already done, we can take the limits for rho phi and z corresponding to the volume specified, which is 0 to 2 and 0 to phi, and here 0 to 5. We should write what is this d rho, d phi and dz. So vector d is 6 rho sine phi by 2, arrow cap. Then 1.5 rho cos phi by 2, a phi cap, coulomb per meter square. Let us try to understand now which components are which. So this coefficient of a rho is d rho, and this coefficient of a phi is d phi. Here there is no z component, so dz is 0. We have to substitute the corresponding d rho and the corresponding d phi and the corresponding dz and find what is divergence of vector d. I'll do it. Continue with me. Now del dot d should be found. Del dot d is 1 by rho dou by dou rho of rho multiplied with this d rho. So rho multiplied with 6 rho sine phi by 2, I will be getting 6 rho square sine phi by 2. Then 1 by rho dou by dou phi of 1.5 rho cos phi by 2. Then dou by dou z of 0. You should also note here, this rho and rho cannot be cancelled because this is inside differentiation. After differentiation, whatever is left, that only can be divided by this row. So after differentiation only, you can divide by row. Before differentiation, you must not cancel any factors or terms in this expression. So let us do the next step, differentiation of this. So rho is the variable. You can take all other things constant. So 6 is constant, sine 5 by 2 is constant. Now differentiation of rho square is 2 rho. For the second term, 1 by rho and 1.5 rho are all constants. You have to differentiate cos 5 by 2 with respect to 5. So differentiation of cos is minus sine 5 by 2. And this function 5 by 2 should be differentiated with respect to 5 and written in the multiplication. So you should get 1 by 2 over here in the multiplication, and the last term is 0. So let us write the final expression for del dot d, which is 12. In this case, after differentiation, whatever row terms are left, that can be cancelled out. So here you'll get 12 sine 5 by 2 for the first term, and the second term also, this row can be cancelled. So you'll be getting minus 1.5 divided by 2 will be 0.75. So sine 5 by 2. So you have sine 5 by 2 common. So 12 minus 0.75, I can write 11.25. So I can write this is 11.25 sine 5 by 2. This is del dot d, which we have evaluated. We can also say this is rho v as per the Maxwell's first equation of electrostatics. The unit for this is coulomb per meter cube. So this has to be taken into volume integration to find our right hand side. We know our right hand side is volume integration of this del dot d. Whatever we have taken here, that has to be done volume integration to get the right hand side. So let us do that now. So our right hand side is going to be volume integration of this del dot d dv. So I will write it as volume integration of 11.25 sine 5 by 2, and dv is, we know, rho d rho d5 dz. The corresponding limits for rho 0 to 2, phi 0 to pi, and z 0 to 5. So the corresponding integration should be done to get the right hand side. So 11.25 is constant. Integration of rho d rho is rho squared by 2 with limit 0 to 2. And integration of all these are in multiplication. So integration of sine 5 by 2 is minus cos 5 by 2 divided by 1 by 2. The limit is 0 to pi, and z limit is 0 to 5. So when you substitute, you will be getting 11.25 into 1 by 2 into 4. Then multiplied with 2. This 2 in the denominator, I'm bringing this 2, 1 by 2 in the denominator, I'm bringing to numerator as 2. And we'll get cos pi by 2, 0, minus of cos minus 1. So into 5. So altogether, you will be getting the answer. This 2 and 2 can be cancelled, and you will be getting 11.25 into 20. So that is going to be equal to 225 coulombs. So that is the right hand side. So I can write the right hand side and left hand side together. So closed surface integration d dot ds equals to volume integration del dot d dv. Both is becoming 225 coulombs. So thereby we are proving the divergence theorem, taking the vector d in cylindrical system as per the given volume in the question. Thank you for watching the video.